Hi everyone, and a very warm welcome to, for some of you, your second year in the Computer Games Development Programme at the University of the West of Scotland, and for some of you, your first year, if you're in fact a direct entrant from college. So very warm welcome, and I hope you're having a good day, that you're safe and well in these unprecedented times. I know that we're not off to a particularly good start for the year, but we'll see what we can do. Everything will be sort of remote, and I'm sure we'll cuddle through. We've been told to be very, very creative, so I've decided to try and perform my lectures where you can in fact see me. Obviously I can dress as I wish because I'm in my own living room, live from my living room. Well, not really, it's recorded. But I've decided to go with just talking through the slides so that you can see what I'm sort of doing. And I prefer to be sort of animated and walking about when I'm lecturing anyway. But if you don't like this delivery, do let me know, and I can just do a PowerPoint slide, and it can be my nodding, bobbing head, boring head, sort of talking through it. So this module is software development for games. And the code is comp08091, I believe. My name is Dr. Thomas Haney. Some of you will have encountered me before in year one, and some of you, this will be your first experience. So you can call me Thomas, Tommy, or Tom. This is my email address, and that's absolutely cool. So, who am I? I'll give you an entire slide on that. Who are you? I sort of slightly know some of you from last year. I know there's some direct entry students as well joining us, and I know there are some Erasmus students. In fact, I have all your lovely pictures over there in the register. You all look, yes, very nice. Not like serial killers at all. So yes. Welcome. So I would normally do a sort of ice breaking exercise, and obviously it doesn't work in this particular context. So I'll give you a module overview. Selected language for this module, which is going to be C#. The learning outcomes, we'll do an overview of what the potential lectures are going to be, the lab topics, and the assessments. So there's going to be a class test, which will be on data structures, algorithms, UML, diagram construction. And then there'll be a practical implementation of possibly a list data structure. I haven't quite decided yet. It can be a list data structure. Now, some of you have actually used C#'s predefined list last year, but what I was going to ask you to possibly do in this practical is to design a list yourself without using the predefined list in C#. So there's going to be labs as well. All of them will be allocated a mark. There are 7 of them. I'm not sure how I'm going to distribute the marks yet. So that's the way we're going to play it. I'm Dr. Thomas Haney, as I've said. That's what I look like generally. I'm standing in my office there next to Pennywise the Clown. He is with us in many guises this day, and that's absolutely cool. That's my mobile number there, 0771 267 3509. Please feel free to phone me between the hours of 9 to 5, Monday to Friday, sometimes possibly even at the weekend. Oh. If you stalk me, I will just block you, unfortunately. It's happened before. Anyway, my premise there is, if I were in my office, you'd be able to pick up the phone and phone me anyway. So you may as well have my number. Please don't send me endless texts with endless questions like some people are doing at the minute. I gave the first years my number, and I received a text this week with about 15 questions in it, and you're saying to yourself, why wouldn't you just give me a phone? I know that millennials don't actually like phone calls, and I don't imagine that that's going to be particularly good for employment later on, so I would get used to phone calls. But anyway, what's sort of happening at the moment is we're developing this we're moving to this new VLE system called Aula, and for the first years, and essentially they prefer to be communicated with textually, and they can't seem to be able to read and understand words like asynchronous and induction, and they don't like phone calls. So where does that leave us? It's all fun. So anyway, do feel free to phone me. There's my email address. I'm the program leader of computer games development. Gavin Baxter, Dr. Gavin Baxter, is your second year leader. So if you have any difficulties, just come to me, or you can go to Gavin and he will come to me anyway. So program leader and the supreme overlord of this program. As simple as that. Module coordinator and a number of modules, but particularly the one that is relevant to you is software development for games. Okay, so here's some of my background, and it's just to sort of let you know of the computing background that I sort of come from. I've always been in academia, really. I do have an HND in software development that I obtained from Ayr College back in 1900. And then I went to Paisley University where I did a BSc Honours in Software Engineering, and I got a 2-1 distinction, but that's back in the days when degrees were actually quite hard. I have an MSc in Advanced Computer Systems Development as well. I then did a PhD in Computer Science, particularly associated with games-based learning and serious games, and if some of you actually survive the course and make it to year 4, I do an entire module in serious games, and if I live too, it's a thing. So hopefully we'll both get there, or all of us get there. I also have a postgraduate certificate in teaching and learning in higher education, and a Master's of Education in higher educational practice. So that's just to sort of make you aware that even though I'm a bit of a joker, I'm more than qualified to teach you, I assure you. Because we're moving over to that new system, it's quite interesting because I've had to meet with a number of learning designers and they're trying to give you their opinion on your material. And you're going, well, unless you have 2 degrees in how to teach these people, I'm really not interested. But I didn't say that, but you know, you're kind of thinking it. So that's where I come from. I programmed in Delphi, Visual Basic 6, C, C++, COBOL, Ada, to name but a few. And after all of that, here is my confession. I'm guilty. Oh, Tyrion hasn't appeared in front of the deck. I'm guilty. I'm not really a particularly great programmer because programming requires an awful lot of work, a lot of rehearsal, a lot of repetition, and a lot of time to dedicate to programming, even in a day, I would say. So after all of that, I sort of went into academia more. My friend who is a senior developer, who is now a bloated alcoholic suicide, working for a company, going round about fixing all the junior developers' work, sort of went into industry, and I went into academia. So I don't necessarily keep up to date with all the sort of newest coding principles, newest coding languages and whatnot, but I do have sort of underlying knowledge of it. So basically, I'm not brilliant at it. It's not my main focus, but I'm reasonably good at it. I have learned it for about approximately 2 decades, so that's fine. But you do get other people in the department that I would say are more technologically proficient than myself, Dr. Paul Keir and Dr. Marco Gilardi, to name but a few. But yeah, you'll encounter them at sort of later levels. Okay? So I've got Gandalf here. This code from last month. I have no memory of this place. So yes, computer programming is a highly complex skill. Many pedagogical issues are associated with it. Considerable time is required to effectively learn that skill, maintain it, and keep it up to date. Rigorous computer programming has been introduced by the Department for Education in recent years, and it's proposed as a skill that everyone should really have. So you get websites like codeacademy.org and code.org, and it's considered to be a sort of glamorous path to employment. And you'll always find a job if you're a programmer. I mean, I could even go out into industry and probably find a job as a programmer right now, but I choose not to because I have an obsessive disorder where I'm a crazed perfectionist, and if I can't get code to compile, it upsets me, and I can't sleep. I lose sleep, and I lose joy, and all that sort of thing. So it's not entirely for me. I don't like chain smoking and thinking, oh, I'm going to lose the company. That sort of thing. So it can be seen as a glamorous path to employment if you like it and if you want to sit in a room and program for life, basically. So that's absolutely fine. I mean, it's a bit like writing, I suppose, where you consider that a very, very glamorous profession where you think, oh, J.K. Rowling, I'll write all of this, the Harry Potter novels, and I'll have millions and millions of pounds and everything will be hunky-dory. But also, the bad side of that is it requires an awful lot of work. You've got to immerse yourself in it. There's a lot of isolation associated with it as well, and there's lots of pressure associated with it too. Because I mean, people are always on you saying, "Where's the next version? Where's the next book?" You know, if you got that code compiled, where is it? That sort of thing. So it can be seen as a glamorous path to employment, but not always, only if you love it. Almost all students enrolled in a department related to the computing field, whether that's computer science or information management systems or whatever, are required to take a programming class at some point. So it is extremely important. Some people more or less sort of manage to avoid programming for their entire lives. And you would be very, very surprised how many people are computer games technology or computer games development graduates or software engineering graduates that will come out and say, I hate programming, I barely did any of it through my entire degree. You do get sort of conversion IT courses, master's courses, where people sort of try to either come back from industry and try to get more qualifications because they're wanting to do something else, or you can get people that are trying to change their direction. Maybe they've done a sort of history degree or whatever, and they decided that they'd rather go into IT because they can't get a job in whatever they've studied at undergraduate level. And essentially what can happen there is someone will say, well, you're a professional programmer, you used to be, so we'll go into a group and you do it all, and I'll work in the documentation. So you do get people that manage to avoid it, although it's extremely important, and I'm assuming that you people don't want to avoid it. So, despite the fact that employment opportunities for computer scientists are rising, the number of students enrolling or in graduating from computer science related degrees is in fact declining. So, the majority of attrition takes place in the first 2 years of a degree program. These are just facts that I have discovered, and it is entirely true. People think, particularly with games development, playing games is entirely fun, but it's different from developing games because that is quite a hefty intellectual process. And as you can see, I'm very, very into playing my games. Went a bit nuts during lockdown. I have many games. I have Mario All-Stars 3D and Mario Odyssey, and I have Switches, and I bought too much. Anyway, never mind. So, the majority of attrition happens in the first two years, okay? Fewer students are actually choosing a career in computer science. Sometimes it just sort of happens to them, but they're not particularly going for it. Although I will say this, computing is forever. I have a lot of sort of real scientist friends that sort of look down their nose at me a little bit because they say, you're not a real scientist, Thomas. And you go, well, duh. That's entirely true. But I could always find work quite easily with absolutely no difficulty because it's computer science, because it's a sort of pseudoscience. It has elements of maths, physics and all that sort of thing in it, but it's also elements of social science as well. Whereas if you're a physicist, it's very, very, very specific, and people that do PhDs in physics or chemistry is entirely specific, and they have difficulty finding jobs in their specialism. Whereas our specialism, computer programming or computer science, is a little bit wider and has more scope for opportunities, I would say, particularly since we're in a sort of technologically driven world where computers are, at this moment in history, ubiquitous. God knows what's going to happen in the future. I'm just waiting to see if there's going to be one person that volunteers to be jacked in like the Matrix, where my Facebook notifications have come up in my eyes, all that sort of thing. So goodness knows where the future is going to lead us. Number of identified issues associated with computer programming and competency. So basically industry expectations in terms of competence and capabilities. The graduates do not meet them. So we're going to have to try and work on that. Teaching introductory programming is a multifaceted problem encompassing issues of abstraction, algorithmic thinking, debugging, and software construction. Okay. So it's perceived as highly difficult with high levels of attrition. Dietz and Bai say that novice programmers often struggle with many underlying concepts and misinterpretations, and it takes about 10 years to turn a novice into an expert. And you kind of notice, I would say, it's my observation in life, that people that are experts or specialise in something do not state that or don't tell people I'm an expert in this or I specialise in that. Generally, you just get people that are good enough don't necessarily have to toot their own horn, I would say. But anyway, it takes about 10 years to turn a novice into an expert, particularly with regards to computing. So, other problems: confusion with branching, location within programming logic, difficulties in the composition and coordination of programming components, understanding error messages and appropriately dealing with them, thinking in the particular programming syntax. You've got to think in operational abstraction levels and things like that. or the specific language that you're in. Difficulty in the visualization of constructs to given problems, and learners require well-structured, timely feedback in response to their actions. But in saying that, despite all those problems, computer programming can lead to a highly rewarding, lucrative career with people like Alan Turing. I've got Margaret Hamilton in there, and that's the code that was required for the Apollo 11 guidance system, I believe. So you can imagine if you found an error in that, it would be horrible. Bill Gates, billionaire. No one could have predicted the coronavirus or the pandemic, but Bill Gates apparently did. I saw a video and he did actually predict it. But he's earned billions, of course. And Tim Berners-Lee, Mark Zuckerberg, who has connected us all and yet simultaneously managed to ruin our lives. Because all we really do now is go on Facebook and compare our lives to other people and say, oh my goodness, I wish I had that. I'm so hopelessly competitive and depressed. But anyway, never mind. Earn billions as well. So the average software engineer can earn about 25k to 59k. So that's good news, everyone. Now here's some examples. If you work for Amazon, 47k, Facebook, 71k, and you need money. You do need money. There's no getting away from it. I earned, before the economy crumbled, I earned £10,325,000 a year in banking. And I had a very, very active social life, and now I earn about £48,000 a year plus benefits and all that sort of thing. And I'm always constantly phoning up asking my mother for, cash because I'm skint. What have you done with your money? Well, I bought everything. I bought the Nintendo Switch and all the consoles and everything, and Protein Bar Mountain over there. So I bought a lot, sorry. So you need tons of money in order to maintain your lifestyle. That's something that I always have to be reminded of myself when I sort of get upset and I don't want this job anymore. People always say, but how are you going to afford all those personal trainers? Well, yeah, I've got to keep it up. So Bloomberg LP 63k a year, BBC 32k a year, that sort of thing. The average gaming programmer salary in the United Kingdom is about £31,000. A Unity developer will get £41,000, Unreal £60,000. If you work for Nintendo, $115,000 perhaps. Sony PlayStation £50,000. An Xbox developer, you take a £500 pay cut because it's £49,500. Great. So the point is, it's true that money can't buy happiness, but somehow it's much more comfortable crying in a porcelain on a bicycle, and I absolutely love that. But yes, the point is, if you're a proficient programmer, not even proficient, if you're half decent at it, you'll always find work, is the point. Okay. So what does that tell us? Programming is hard. You can't learn it from a book, although books are helpful. These are all your reference points. You've got the entire internet nowadays, all your books, papers, things like that. So it's all down to practice, and you must practice if you're wanting to go that particular way. Requires a great range of skills: vision, problem solving, coding knowledge, accuracy, power of deduction, confidence and concentration and organisation. So you need to be able to see a problem, envisage a solution, craft the code, avoid the errors, fix the faults, maintain morale. Maintaining morale at this particular moment in time is incredibly difficult because we've all been through the ringer. And you've got to be very, very sort of patient with these things. You can't just think it's the end of the world every time you encounter a problem with a program. I've done this job for approximately 8 years, and you always find someone in the lab that goes, oh, I can't get it to work. Oh, I've tried it. It's not compound. It's dead. And all that sort of thing. Then they call you over and they scroll up and down the screen of the code El Rapido as quickly as they possibly can, with the goal in mind of making you go, get out of the way, I'll do it. Whereas you've got to take a step back, breathe, stillness, be patient, that sort of thing, and get into it. My friend, who was recently having difficulty with his iPad, because it's just upgraded to iOS version 14, was finding that when he was putting his dongle into the iPad, the import button wasn't appearing anymore. And he was telling me all about it. He came to me with the problem, said, bring it to me, I'll have a look at it. And the only thing I have is infinite patience. When I get to the gates of St. Peter, he's going to say, why are you allowed in here? I'm just going to say, I was the program leader of computer games development at the University of the West of Scotland. Step aside. And in I go. But anyway, all I have is patience and the ability to look at things very, very carefully, clearly, without getting flustered. And I was looking at it, and all the way through it, he was yittering at me, well, I've tried looking on the internet, Thomas, and I can't actually find anything that says that this is a problem for everyone, which means it's only a problem for me. Yes, that's fascinating. And every time I actually put that in, if I put the charger in, then it seems to be okay, but it doesn't seem to connect with that particular thing there. So I don't know if it's a problem with the charger. It must be a problem with the... Shh! Calm down. Take a moment. Take a breather. And let me work my magic and shut up, for God's sake. So I eventually sort of found the issue, and what had happened was, because the graphical user interface had updated, now at the side you have a little thing called devices, and you select that, because iPads, as you know, are very, very sort of touchy, and it's a bit like Game Maker, I would say, where everything is sort of hidden from you, and you've got to just know where to look. That's it, really. So I selected devices, and it was an untitled device, and there all these pictures popped up, and there was an import all, and all was solved. But it took us approximately 20 minutes to find that. Maintaining morale, maintaining standards, and maintaining control. Okay. So this is a course to increase your confidence, to help you become familiar with more software development and games development concepts, algorithmic complexity, data structures, algorithms, UML, you name it. And the opportunity to undertake some exercises as well. The objective being that you can actually create abstract models and implement them and recognize these things in a games context. We're supposed to present these findings back to the class, but that's not going to be happening this year, because there's going to be no class. No one is coming near me with the corona. Well, no one's going near anyone, really. So, got to be remote. We've got to do it. A more in-depth look at the object orientation, we're going to look at that. So how to build classes, models, objects, and relationships. So methods, functions, encapsulation, inheritance, polymorphism. We're looking at that in more in depth. And we'll look at some design and implementation, some UML notation as well, and object-oriented design. And we'll consider these in a sort of gamey sort of way. In addition to all of that, this module was originally supposed to be a concatenation of many modules. So it was supposed to be abstraction and specification and program development, dynamic algorithms, data structure files, and structure and algorithms, and what else? Something else. But anyway, it was supposed to be combining it all into one. And as a result, it was very, very difficult to do that and get all the relevant sort of material. So the idea is it's supposed to give you an underlying knowledge of software development principles. Now, I can tell you that the external examiner is very happy with my efforts, but obviously I'm only covering a subset of everything. So, we're looking at, in particular, arrays, multidimensional arrays, recursion, sorting, bubble sorts, insertion sorts, selection sorts, searching, lists, linked lists, doubly linked lists, circularly linked lists, stacks, queues, trees, graphs. We're looking at all these sorts of data structures, and applications and games will be considered as well. We'll also look at graphical user interface implementation principles, and we shall look at human-computer interaction, which is highly important as well. So, the module is designed to make you think about the software constructs and games, give you the underlying knowledge. Because we've got a mix of direct entry students coming in, and we've got people from the first year, it is supposed to be enough time to get everyone up to approximately the same level, if that ever happens. But anyway, that's our attempt at it, and that's the way it's supposed to be. Okay, and to engage you in interesting exercises, allow you to become proficient in another language, it says, but allow you to become proficient in this language anyway, and to conform to these particular standards as well. So the module language is going to be C#. Most of you will know C# anyway. As you go through the years, I think it's Game Engine 1 and Trimester 2 that you'll actually be using Unity, which of course uses C#, and later on you'll be using C# and Game Engine 2 as well. So we're using Visual Studio 2019 Community Edition, which is freely downloadable. There are instructions on how to download it next week, so hopefully we can get everyone sort of up and running on that. So good. C# is a bit easier to pick up than C++. C++ is phenomenally difficult. Let's face facts, it's far more difficult than C#. We have one module with a bit of C++ in it later, which is called Computer Game AI. And games console development, I believe, is in C++ as well. So you've got to possibly learn a little bit of C++ as you go along. but C++ is far more difficult than C#, obviously, and that's just it really. Regardless of programming language, you should be able to pick up any programming language at the end of this course, and it shouldn't be a big deal to you. I used to work for a professor where every time he was going to start me on a new project, I would always be chain smoking, going into his office, going, "Oh God," and he would always pick a programming language out of the ether, more or less. I think we should possibly develop this in Java, or maybe C++, who knows? And he would go, or Visual Basic. And you go, "Oh, that sounds a bit better, to be honest." So you've got to be able to program and everything. You've got to be good at everything nowadays. There's no pressure. Good at everything. So what you will learn: simple and complex data structures, how to implement various data structures, and how to implement sort and search algorithms. Now, C# actually has sort of set data structures for you, so that's good. But the main point is, programming language is more or less irrelevant. It really is just a tool. Throughout your software development career, your games development career, you use a number of them, and you'll eventually get over this requiring a blood pressure cuff every time a new one is mentioned, sort of stage. So this is an interesting exercise to try. If you write a program in one language, how long would it actually take you to write that same sort of program in another language? Probably not too long. Like many things in life, your first one is the toughest. It's just a tool. It's really about communication. When it boils down to its bare bones, you're instructing a machine on what to do. So efficient communication is required. No programming language is a one-size-fits-all. The choice of programming language can change based on the type of problem that you're attempting to solve. So for a robust server-side enterprise software, you'd probably choose Java or something like that. Data science related, possibly Python or R or whatever. So my advice is to master the basic programming concepts described earlier, and then you're at a good sort of starting point. The other thing is, the programming landscape evolves very, very quickly. There's always new frameworks, there's new languages, there's new standards. Sometimes they even try a hint at a new sort of programming sort of philosophy. We had agent-oriented programming instead of object-oriented programming back in the late 90s, I believe. So the point is, it's an ever-changing sort of thing, and you've got to adapt fairly quickly, and adapt without having a coronary every single time that you're asked to deal with change. Now, coping with change is difficult for humans, I grant you, but that is the nature of life nowadays. Despite all of this, if you're sitting there, trying to get something to compile on a computer, it's not really working, 6 months in the acid mines, is it? So you've got to keep a sense of perspective. Lectures, today is the introduction, there's no lab. Try and possibly install Visual Studio 2019 Community Edition if you like. Next week is going to be methods, functions, debugging, performance and timing, because efficiency and timing is relatively important, particularly when you're looking at games, which is sort of resource intensive. And it's quite nice to sort of time things and see how efficient or inefficient a bit of code is. So there's a small lab on that. In classes, encapsulation revision, inheritance, polymorphism revision, and someone, as I say, did say at a sort of, or did I say this, a student staff liaison group meeting last year did say this is rinse and repeat, more or less. And you go, well, it's a bit of revision, certainly, but I mean, if it's rinse and repeat, why didn't you get a grade A for both of them? So there's new things in there as well, but it is a consolidation synthesis sort of module. Polymorphism revision as well, and then the next week after that we may have a break, a consolidation week. Then in the 20th of November, there is a UML diagrams, object orientation, arrays revision lecture. Oh God, and that particular day I'm turning 40 and I don't wanna, oh, never mind. So I'm turning 40 that day. I can't believe where the decades have gone. But anyway, after that, then we're going to look at abstract data types and stacks, queues, lists, and we'll talk about the coursework in sort of due course as well. So that's a sort of provisional timetable. So it's jam-packed, so it's good. Assessments, there's going to be a completion of a number of labs. I haven't quite decided the distribution of the marks yet. The way this module has been set up, it's 40% of a class test, and it's 30% labs, and it's 30% of a practical. Now, you've got to get 30% in each particular component, so there are 3 components of assessment in order to actually pass. Now, some people managed to do 2 of the components last time and didn't even bother submitting a practical coursework because they thought everything was hunky-dory. So I'll see that the distribution of the marks here could very well be, we could have 4 labs and then make a little, some of the labs possibly put towards some of the practical coursework, so that they at least get the required marks or the required 30% to get through, and it doesn't hold them from passing the module, because it is a bit annoying, to be honest. So it should be about 30%. There are 7 labs available, and there are 2 or maybe 3 associated with data structures. And if you complete these, then everything should be fine and you get full marks. The class test is specifically an object-oriented programming concepts, algorithms and data structures, and it's going to be multiple choice questions, possibly about 75%. And then there's open-ended questions, which is about 25%. So a construction of a UML diagram, basically because all of this is going online, I expect that all of it will be multiple choice, but I'll try and develop these things and we shall see. Implementation of a list data structure might be worth about 30%. I haven't put out the coursework yet, although some of you may have managed to sort of pillage it if you've seen the MyUWS from last year. And we'll see. It may be a list data structure that you constructed yourself. Maybe make it 20%. I don't know. I haven't quite decided. I would like your input on that. We'll see. We may have a Microsoft Teams meeting to discuss that and see how people feel about it. So insertion removal, making the list persistent, sorting. Unlike programming with objects, the underlying programming is all your own and not C#. And what I mean by that is, if you're doing a data structure, I don't want you to use their predefined data structure. I want you to actually implement your own. So that's difficult. When I was in 2nd year at university, we were implementing binary trees and graphs, horrible data structures. A list is just a simple one. So don't worry about it. Assessment checklist. This will be a proposed assessment checklist. So class test will always be worth about 40%. Labs will be worth 30%, regardless of how many there are. And then there'll be a practical implementation of some form of data structure, which might be 20%. I might make these sort of seep in here, if that makes sense. Okay? So some of the labs may contribute towards that in order to give you a sort of pass. Okay? Or if you've been in programming with objects before, you can submit a sort of list, predefined list, in order to get a pass, or you could possibly do that if you're new to the course as well. Last year someone decided, oh, this is too easy for me, I want to do something else. And they did an implementation, or tried to do an implementation of a binary tree. So if you're unhappy with the assessment when it comes out, do speak to me and I can always assign you a more difficult one. It's no problem at all. So I gave him a binary tree, and ironically he ended up getting a lower mark than the majority of people. But I'm quite happy to rewrite assessments and be creative in school. Also, if you have any special burning desire to use C++, it's also acceptable to do so. I've got no difficulty with that. The only thing I will say about C++ is that there'll be very, very little support in it. I can do some C++ support to a little extent, but I'm not really wanting to spend hours and hours and hours with one student that wants to do C++. I've done it in the past and it just eats up all my time. So probably just stick with C#, how's that? But I'm up for the idea. Okay, implementation of a particular data structure could be any data structure that you actually like. I don't really mind. Think about it, possibly stretch yourself, or just play it safe. I mean, it's entirely up to you if you're wanting to just let the knowledge sort of seep in. You might find that you have other challenging modules this year, and this one doesn't necessarily have to be that challenging if you don't want to push yourself. For a sort of basic overview of programming, then it's good. But if you're wanting to try something else, you're not quite at that level, you're too advanced, then we'll work it out, is basically what I'm saying. So, insertion, deletion, sorting, searching, displaying, a menu structure, possibly a doubly linked list, a circularly linked list. I've done all the data structures. It means very little to me what one that you want to use, but I would probably stick with a list because it's easier. Okay. I did use a sort of dinosaur game in programming with objects. So we had Jurassic World Alive. That can you can come up with some form of game structure in order to hold or make the underlying data structure interesting. So you can have a sort of game on top of it. I don't know. I just used Jurassic World Alive because you could have a number of dinosaurs and a number of characters. But you can have a number of objects and characters for any form of game, so it's entirely up to you. I mean, it really is a sort of, perhaps, shall we say, inventory system for a game, where you have a character and they have a particular inventory. So there's Link there, he's got his sword, his shield, whatever. You can do that sort of thing as well. And it's really up to your own imagination. Whatever makes it better for you, okay? And that's going to be worth about 30% of your mark. Why is that there again? Oh, right. So that's the sort of structure that I used last year. Why did that happen? I must have copied that inadvertently. Okay, so that's the sort of structure that I used last year. We had Jurassic World Alive, we had a character, we had a number of dinosaurs. Some people managed to make their dinosaurs mate and create other dinosaurs. It was disgustingly impressive. So you can do things like that if you want, or you can use any other sort of structure for a game. Even sort of, you know, Mario. He's going along. He does have sort of power-ups and basic inventories as well. So mushrooms, the flowers, all that sort of thing. And you could be carrying all of these things at one time. Entirely up to you. You can base it on whatever makes you feel better. Additional apps. So there's the learning outcomes again to have a look at. Additional study apps, there are many of them. You can download them from the App Store or the Play Store, Android, whatever. And I found these particularly useful if you're, not that anyone's going to be sitting on a train nowadays, but if you're sort of sitting there and you're wanting to you know, just have a test of your knowledge, you can have a look at these particular apps. Okay. What is happening to me? Okay. So, to summarize, why should you become a programmer? Job availability, you always find work. It's a hard, specialised skill, can be high paying, money is brilliant. Flexibility in terms of working from home, particularly nowadays. We can just you know, set up shop, and as long as we've got a powerful enough PC, which you can have Amazon deliver in a nanosecond, then everything's fine. It can be challenging. There's an art of creation to it. It can sometimes be considered as relatively cool, although not always. So those are reasons to become a programmer. Reasons not to become a programmer: if you don't like programming, you have to constantly update your skills. So, I mean, don't just simply say, I want to learn this amount and that's me forever, like a sort of secondary school teacher. If you're going into management, it does require a bit of overtime, but any job requires overtime nowadays. I'm supposed to work 35 hours a week, and if I only work 35 hours a week in my job, I wouldn't do my job very often. So overtime is part of really any job now, or any high-paying job. It's what's expected by society, I would say. And as a result, you're wanting a job that you love. And I love this job. Okay, so programming skills, problem solving, debugging, determination and perseverance. You're constantly willing to learn. You have an insatiable lust for learning. You're willing to research, experiment, communicate, write specification documents, product release, writing tests, testing code, and it really has to be a little bit of an obsession. Not an obsession that I would term an obsession, because when I become obsessed with things, it is quite beyond belief. But anyway, that's the skills you want. Game programming skills, you need enthusiasm, you need to work on projects of your own, put them in your e-portfolio, get them onto LinkedIn. You're always learning, looking at magazines, conferences, websites. And the pragmatic programmer recommends that you learn one programming language per year. So this is all sort of basic stuff. One thing is you play games so that you can appreciate the sort of finished product. I play games quite a lot. Well, I don't really play games a lot, but I play games just to come up with ideas and realise, you know, what my appreciation of games is, I suppose. And generate ideas for you guys, and to also appreciate the final product, and see how games have actually sort of, this is a good example here, where Super Mario 3D, see how games have actually advanced as technology has advanced, and it's quite neat to see. So this is back in 1996, and then another sort of version, and how little sort of bits of programming have recycled themselves. And if they've recycled themselves, have they recycled themselves well? One of the things I've always been really upset with was the three sort of sequence jump in Super Mario 64 that didn't transfer well to the GameCube, and it's transferred. It hasn't transferred particularly well to the Nintendo Switch either. So I get little pieces of appreciation in terms of design and programming there. Skills: C++ fluency, C# fluency. Linear algebra is something you might want to look into. Good software engineering, even if you don't find a job in the games industry, a good software engineer, you will have a good software engineering sort of grounded knowledge, shall we say. So, good practices, object-oriented design, and the ability to get things done. Now, one thing about a degree is it shows, because you can quite easily probably just go and learn all of these things in Udemy or YouTube or whatever. The Unity courses that we have here is an excellent example of that, where you are learning how to program in Unity, but the academic can't possibly come up with better tutorials than Unity have come up with themselves. And you sort of question, well, why should I be doing this then? I just learn it here. But the degree formal structure allows you the ability to say, I've got this piece of paper at the end. It was 4 years. I didn't enjoy every aspect of it. I enjoyed some aspects of it, but I got it done and I committed to it. And that is worth its weight in gold. And you've got to prove that you can stick with things. I'd say that's highly important. So, well-rounded education as well. So to quote that sort of Blackadder episode, I am a well-rounded human being, with a degree from the University of Life, a diploma from the School of Hard Knocks, and 3 gold stars from the kindergarten of getting the kicked out of me. So, well-rounded education, lots of hobbies as well. I once decided to help someone with a reference in a CV, and we found out they had no hobbies whatsoever. They just sort of played video games and programmed video games. And he was a brilliant developer. And eventually, when we sort of got to that bit, it's like, don't you have a hobby? Something? Anything? And eventually, about 25 years ago, he studied archery or something. Not studied, but did some archery classes, and fired a bow and arrow. So, I mean, it's nice to have some hobbies outside of these things to prove that you're slightly normal. And it allows you to approach these things in a different perspective. So, game programming, it's demanding, it pushes the programmer to its limits. It can be extremely resource intensive because it does push the computer to its limits as well sometimes. And it requires a lot of hard work, dedication, perseverance, and promoting yourself, which Scottish people do not like, and positivity. And I will tell you this, employers do not like negative, obstructive people. They just don't. They prefer positive, and regardless of what you're asked for, yeah, that'll be fine. I'll get the solution to that. It's absolutely awesome. So positivity, and they like go-getter, problem-solver people, not negative people that always come up with a question or some form of obstruction, or I can't do this because. They want, I can do this because. So they want positivity. I can tell you that much. Okay? How to learn programming, listen to someone talk about it. I've been talking about it a lot. Watch someone program. I suppose I have decided that I'll possibly do some possible videos for the labs if you require them. I've got screen capturing software, so I can basically just program it all. I suppose if you need that, hopefully the labs will be sufficient. So you can watch someone else program. There's lots of sort of tutorials on YouTube and things like that. Reading a book about programming is one way to sort of, although it's not the best way, these are sort of reference things. Talking about programming, planning a program, and looking at someone else's program, paired programs as well. You sort of do that all the time. You get the solution first. I see. And working together, that's how you learn to program. Also, fixing someone else's mistakes. I always sort of say this. My friend who's the senior developer, and I was always slightly better at programming because I could always put my mind to everything. I have this crazed obsession. Whenever I put my mind to something, I've got to solve it. So I remember one particular time I was trying to remove a node from a binary tree, and I was sitting there until 4 o'clock in the morning trying to work out why my algorithm didn't work. And it was eventually, I successfully managed to establish that it was because his insertion algorithm was incorrect. So the tree was formulated in the wrong way, and that's the reason that my algorithm didn't work. It was actually his algorithm that was the problem. So I remember scribbling into a notepad, "Stuart is an ass," at like 4 in the morning. So also trying to fix other people's problems is very, very educational as well. And of course, by programming. That is the way to do it. Next week, we'll look at the revision of methods, functions, and some debugging and some timing and profiling. And then we'll start the labs. Do try it, and there are instructions that I've got to download and install Microsoft Visual Studio 2019 Community Edition. But I wasn't going to make them available until next week because it sort of slightly gives a bit of the lab away. But try and download it this week. Make sure that you click on the C# version and give yourself the ability to do C++ as well. But don't worry if that is an abysmal failure, because we will get to it eventually. I'd imagine that most of the people that did programming with objects will have that. But basically, I have everything installed in my machine here. I could screen capture the entire installation process, but then I was thinking, why would I upset my installation when it's perfectly stable? It's lunacy to do so. So one of the things about being a software engineer or a programmer or a games programmer is that you constantly have to install software and work out the little quirks of software as well. One particular interesting quirk right now is that we're all sort of using Discord, and Discord at my parents' house does not bloody well work. It doesn't seem to communicate well with PlusNet. So next week we'll start the labs. There will be instructions and everything like that. And if you do have any difficulties, then email me or phone me. Okay, right. Very warm welcome again, and I hope you enjoyed that. And there'll be much more to come. Okay, bye then.